All right, so let's talk about the next one of these longer projects I've written here, which is going to be 34 this time. And notice it's all extra because I planned the future, and 33 would be the last required project. So I'm going to have to add a lot more, I think. I don't get bored of them. But anyway, at least this time I'm teaching it. These are the only ones that are going to have required points. All the rest are going to be extra credit. So we're going to end up with a ridiculous amount of extra credit. So this will be an easy A for people who solve problems. But that'll do, especially for the first time. Anyway, so I love these. I do them for fun. Like I say, I've been doing them for years for fun. That's why when they said teach this course, I said I know what I'm going to use for homework. I've been doing this for years. So hexagonal tiles. This one was very interesting. There are quite a few pitfalls. So you're installing a tile floor. The tiles are hexagonal, like this here. Yeah. Okay. Now you want it. Hex grid, you want to make them in a particular color pattern. The tiles are all white on one side and black on the other. They all start with the white side up. And now the room is as large as it has to be to fit any kind of pattern. We're not going to have any edges or wraparound or anything. So they're going to give us a path. We're going to start from a reference tile somewhere in the middle of the room. It doesn't matter where. And then I'll start it at 1. And then we're going to traverse a path to decide which tiles to flip. So here, this path. The path is just a series of letters with no delimiters. But there are only 6 possibilities. East and west, which is, you can see it up here. East is to the right and west is to the left. So 2 is east of 1, and 1 is west of 2. East and west are normal, but then you got these diagonals, and those are southwest and northwest, southeast and northeast. And if you wanted to be picky, those aren't exactly right. This angle with 45 degrees for southwest, but this is actually 60 degrees. But anyway, it'll do to label them. So there are 6 neighbors to each tile going around it, which is an interesting thing that leads to strange problems compared to a normal grid, like a checkerboard. Anyway, so here we are. So this specifies the path. So east, southeast. I'm reading this one I've highlighted. East, then southeast, then northeast, then east. So that walking path will get you to 5, and then you flip this one to be black. So this line tells you one tile to be black. And here's another one, east, southeast, west. It's east, southeast, west. That gives you this tile right next to the one you started with. And here's one that takes you back home. Northwest, west, southwest, east, east. You end up right back where you started. So I can give you a few tips. I spent a while struggling with this. So here's a larger example with 20 paths. And when you're done with those 20 paths, you'll get 10 tiles flipped once to black and 5 more flipped twice. So they go back to white. So you end up with a total of 10 tiles black. And I printed this out, which the original problem didn't give you a printout, but this helps me because it's trickier than you might think. But I can give you a couple of tips. There were 2 big tips that moved me forward, and I found them, of course, by writing code which failed and had to debug it until I found the problem. The first thing I noticed is this. You do not really need to parse this. You just need to, it doesn't matter what order these steps are in. So you just count how many, and also the east and the west appear in 2 places. If you were to first get all the e's out of it, you'd be in trouble because there might be southeast and northeast. So what I finally settled on is first I would just count all the southeasts and then delete them all. Then count all the northwests and delete them all. Do this for the ones with 2 letters because all that matters is how many there are. If there's 10 southeasts and 10 northwests, they cancel each other. So it doesn't matter. So you don't need to preserve the order. You don't need to make a list of this and parse it step by step, which is what I did the first time. You just need to count how many southeast, northwest, northeast, and southwest there are, and then how many east and west there are. There's 6 possible moves, and you count how many there are, and then you just make that many steps. And they cancel each other nicely. So that's the first thing that saved me a lot of bother. I didn't really have to preserve these lists. I just had to process them and turn them into a list of 6 numbers, and then I can subtract numbers, like I can take the difference between east minus west, and that's the x coordinate to move it by. So I can boil it down pretty quickly to a small set of numbers. But even then, I still got hosed, and there was a nasty trick. You will get 10 tiles here even if you do this step wrong. But they'll be the wrong 10 tiles, and you'll find out in the next one, which is why this picture helps. And the reason is This is the problem. This is a grid that shows the hexagonal because I put 2 spaces between the dots, and I've added 1 extra space in the odd numbered lines. So now I have the hexagonal grid. But what that means, what I was doing was I was taking southeast and moving 1 to the right, and southwest and moving 1 to the left, subtracting 1 from x, and that's wrong. And the reason it's wrong, you can see here, and this took me a while to understand. Here's element 0 in the x. Here's 0 in the x, 0 in the x. This is 1 in the x, 1 in the x. The neighbors of this tile at 0 have x coordinates of 0 and 1, not -1 and 1. So, and then this one is at 0, and its neighbors are 0 and -1. So there are only 2 x, and it depends on whether you're an even or odd numbered row, what the neighbors are on the next row above or below. That took me a little while to understand, and that's why I say the hex grid is a little confusing. But once I understood that, then I could get the right pattern, and this is the correct pattern of 10 tiles. But I did it wrong. I still ended up with 10 tiles, so I thought I was right, and it wasn't until I got to the next section I realized I was getting it wrong. So I realized it would help you guys to actually see this picture. I had to make this picture to understand the problem. So when you're done, you see how many tiles are left at black side up from a longer data list, much longer. All right, and now we're going to start with the output of this, which is a floor with a bunch of tiles that are changed black, and now we're going to do something like the game of life with it, with different rules. Any black tile with 0 or more than 2 black tiles flips to white. And any white tile with exactly 2 black tiles flips to black. And so if you take the above example here where we had 10 tiles, you can see things. It took me a little while to understand these rules. The black tile with 0 or more than 2, it will flip to white. So this black tile is going to flip because there are 0 neighbors. This one is going to live because there are 2 neighbors. This one is going to live because there are 2 neighbors. I don't think we have any example here of anybody with more than 2, but we have some with 0 neighbors. These 3 are going to die. The only way you die is if you have 0 black neighbors or more than 2. And right now, these 3 are going to die. None of these are going to die. But white tiles are going to turn black. White tiles turn black if you have 2 black tiles adjacent to them. So that would be this one. That's got two white. That white tile has 2 neighbors. This one has 2 white neighbors. This one has 5 neighbors, so it's not going to flip. This one will flip. It has 2 neighbors. This one's going to flip. Oh, and that's another essential thing. You don't change anything until you choose all the flippers. Otherwise, you'd have a different problem. So first you go through without changing anything and determine all the things that are going to flip, then you flip them all at once. Otherwise, the fact that this one dies would mean this one is not going to get its chance to live, and you have to figure out which one of those operations comes first. So that's easier to understand. You can work from the printout here. We can say this one is going to turn black because it has 2 neighbors, and this one is going to turn black because it has 2 neighbors, but this one is not because it has 3 neighbors. Yeah?
That's actually really a big thing. You see where the 3 have the space in between that you were saying about the living one? It would get the order, no, left or right rather. That area.
Yeah.
No. Okay, between the 2 dots, the little dot between the other 2 dots. Up.
Oh, this one. Yep.
No, to the right.
Okay.
The other 2.
This one.
That dot, yes.
Yep.
That dot. So that dot and the one bottom left of it
Yep.
are both going to flip up to be...
That's right. This is going to turn black because it has 2 neighbors, and this one's going to turn black because it has 2 neighbors. Exactly.
But now the one right next to it, up left, that one that's already black, no, the one already black.
This one here.
No, down one.
This
There.
one.
Yeah, that one now has 3 neighbors.
So next time it will change white, but not this time.
Okay.
That's why I say it's real important to know whether you change and then base it on the altered situation partway through, but you do it all at once. Make one pass without changing anything and just mark the ones you're going to flip, then flip them all. It's real important to know. Otherwise, it would matter what order you did them in and everything. Good. All right, so that's the game. And so you flip them based on that, and to get you ready, for this example with 10, these numbers will help you. And as I said, I found these numbers all wrong because I had misunderstood how to find the 6 nearest neighbors. I was making a mistake of if I start here, I would go +1, which would take me to here, and -1, which would take me to there. treating those two as neighbors of this one, which is what will happen if you just add and subtract 1 to x. But in this case, you have to have, to get to this one, you change x by 0, and to get to this one, you change it by +1. And that took me a while to figure out. Anyway, that's what I wanted to tell you about that. It's good, clean fun. I'm going to stop this recording.